So we are looking at example 9 and topic 3.2, implicit differentiation. So we've got 3x minus the natural log of xy, which that looks kind of like a chain rule, plus y squared equals 11 halves. And they do want us to find the derivative, and they were nice enough to give us both the x point and the y point this time. So I am going to start with my chain rule piece. I'm going to do that off to the right. So y equals the xy. I know I've done this a few times, that we're going to have a product rule there. So we've got that y prime equals the derivative of the red, which is 1 dx dx times the green, and then which is y, plus the red the way it looks, which is x, and then the derivative of the green, which is dy dx. And again, I'm going to rewrite that so you'd get y plus x dy dx. And then just so I've got it, the derivative of my outside would then be natural log of u. A derivative of that is 1 over u times the derivative of the inside, which is y plus x dy dx. And then 1 over u would be x, would turn into 1 over xy times y plus x dy dx. All right, so let's go ahead and go back to our original problem and take our derivative. So the derivative of the 3x would be 3 dx dx. We know the derivative of that, it's going to have a negative in front, and it's going to be this mess right here. So 1 over xy times y plus x dy dx. The derivative of y squared would be 2y dy dx. And the good news is the derivative of 11 halves is 0. All right, then just like we did before, we are going to distribute in this right here. So, and I'm going to at the same time get rid of anything that says dx dx. So I've got 3, and then I distribute in, I get negative y over xy minus x over xy dy dx plus 2y dy dx equals 0. We are going to move it. So I'm going to box my purple and my, actually, no, I'd take that back. We have numbers to plug in. So I'm going to go ahead in this step and just go ahead and that's not what I wanted. I'm just going to go ahead and plug in these numbers here. So, and sometimes that's easier to do than trying to move the algebra around. So I've got 3 minus the y value is a 2 over it's x times y. So 1/2 for the x and 2 for the y. That's nice because they cancel. All right, minus the 2 for the, the 1/2 for the x. And then it's 1/2 times 2 again, which again cancels. And then times dy dx. Plus 2 times my y, which is 2, dy dx equals 0. All right, I'm going to see what happens once I get rid of these denominators here. So I've got 3 minus 2 minus 1/2 dy dx plus 4 dy dx equals 0. At this point, I probably would look at doing boxing my purple for my dy dx's, excuse me, and my yellow for anything that's not dy dx. I know that 3 minus 2 is 1, so I'm just going to move the 1 over to the other side. So the 1 moving to the other side would be negative 1 on the right. The dy dx's I could combine like terms. I'm going to change that 4 to an 8 halves. So I have negative 1/2 plus 8 halves would be 7 halves dy dx. And now I need to get this 7 halves to the other side, so I multiply by the reciprocal, 2/7. So I get that dy dx equals negative 2/7.